I'm just going to show problem 13 from page 240 at the beginning of this video because it seems like I can get through about a page before I run out of time or feel like I'm going to run out of time. So here are the answers to 13. If I don't have another video after this, you'll have to go about halfway through the video to see the answers to 14. So this is A through C. Here is my answer for D. Now I'm going to show you how to do these. 13 says how many, and then it gives me a number of different things it wants me to convert. So for 13a, it wants me to convert 0.256 moles of iron to number of iron atoms. So I have 0.256 moles of iron, and I want to go to atoms. I know that 1 mole of iron contains 6.022 times 10 to the 23rd atoms of iron. My units cancel, so when I multiply these two numbers together, I get 1.54 times 10 to the 23rd atoms of iron. For B, I'm given 3.87 grams of krypton, and I want to convert this to atoms of krypton. Well, I know that in 1 mole of krypton, there are, from my periodic table, right here, 83.80 grams, rounded off to my 4 significant digits. 83.80 grams of krypton. But I'm not quite there yet because I want atoms of krypton. So 1 mole of krypton contains 6.022 times 10 to the 23rd atoms of krypton. When I multiply the two top numbers and then divide them by the bottom number, I get 2.78 times 10 to the 22nd atoms of krypton. Now, if you're getting a wrong answer, but you have everything set up correctly, and I'm going to cancel out my units to show you that they cancel, you may be putting your numbers that you're dividing into your calculator wrong. So check that. If you have it set up right, but you're getting a wrong answer, you may be dividing the bottom number, 83.80, by 3.87 times 6 times to 6.022 times 10 to the 23rd. So double check that you are using your calculator properly if you're getting a wrong answer. For C, I am given 6.17 moles of aluminum chloride. And I want to convert to formula units of aluminum chloride. So I know that I want to cancel out moles. In 1 mole of aluminum chloride, there are 6.022 times 10 to the 23rd formula units of aluminum chloride. And when I do that multiplication, I get an answer of 3.72 times 10 to the 24th formula units of aluminum chloride. And finally, D. I am given 8.58 grams of sodium iodate. And I need to convert that to formula units of sodium iodate. Now, for this one, I can't just look on my periodic table quickly because I have a compound. So I have to figure out the molar mass of this compound. So I'm going to do that down here to give myself some room. So sodium iodate, I'm going to figure out the formula mass. So I look up the molar mass of sodium, and I only have one of that, and that is 22.99 grams per mole from my periodic table. For iodine, when I look that up, I get 126.9 grams per mole, keeping to those 4 significant digits so I don't have a whole ton of numbers to write. Plus, I have a subscript of 3 behind my oxygen, so it's 3 times 16.00 grams per mole. I follow my order of operations, so 22.9 grams per mole plus 126.9 grams per mole plus 3 times 16 is 48.00 grams per mole. When I add all of those numbers up, I get 197.9 grams per mole. Okay? So I go back up here, and I know that 1 mole of sodium iodate is 197.9 grams of sodium iodate. And I know to put the grams on the bottom because my units have to cancel out. That's always the rule. And then I know I'm not quite there because I need formula units. I know that 1 mole of sodium iodate is 6.022 times 10 to the 23rd formula units of sodium iodate. So when I do the multiplication across the top and divide by the bottom, I get an answer of 2.61 times 10 to the 22 formula units of sodium iodate. And the last problem will be in the last video.